Hello, my name is Andrew Davis, and this is my presentation for the Memento software design pattern. The intent of the pattern is to capture and externalize an object's internal state without violating encapsulation, so it can be restored to that state later on in execution. The pattern is largely useful when dealing with risky operations where it's very likely that a class's state will need to be restored to a previous valid state from earlier in the execution. The pattern consists of three main parts. There's the originator, which is the focus class in question within internal structure. There's the caretaker, which is sort of the client and user class that is going to be handling the management of the originator and also handling collecting and storage and restoration of the memento copy of the originator's internal state. And then you have the memento, which is a static copy of the originator's internal state. This memento should itself not be changed between when it's created and stored and when it's actually used to restore the originator to its previous state. UML sample diagram of a memento pattern class. There's the illustrating the caretaker, the originator, which should have some internal state values, and it should have a function for creating a memento and a function for restoring from a memento. And then you have the memento object, which has the state and has mechanisms for setting it up and for retrieving that state. And these are the references I used for this PowerPoint. So this is an example program I put together to illustrate the memento pattern in action. First, we have the data storage originator class, which represents an originator in our pattern. In this example, we have just a string called state. That's our internal state. And we have our constructor, and then we have the save to memento and restore from memento functions, which are key to the pattern. The restore from memento accepts a memento object and restores the internal state of this class to whatever stored in the memento. And then we have save to memento, which will create a new memento object with the internal state passed to it. For the memento object, we have it so that on its creation, it will set the internal state to the state it was given, and then its internal state data object only has a retrieval function. It's read only, and that's done on purpose to ensure that the internal state of the memento is not itself changed between when it's created and when it's actually used. And then for our main class, that represents the client in our pattern, we of course have a variable for storing a memento, and we have of course a variable for our data storage. And so we create the objects, and then we have a simple user interface set up to interact with this program and demonstrate what it can do. And I'll actually pull up the running compiled version here. So first we will input some text, the classic hello world, and then we can see that the current text as stored in the data storage object, the originator, is currently set to hello world. And so then what we do is we'll actually save this current state to a memento, which calls this code here, which is setting our stored memento to a new memento generated by the save to memento function in our data storage. And then we will change the stored text, so we'll make that more of a more weirdly messed up hello world, and we'll see that that's now currently stored in our data storage object. So then what we'll do, because we want our data storage to, we want our stored object to be that proper hello world, we will restore back to the data storage back to the internal state as saved in the memento, utilizing the restore from memento. And then if we check our current stored text now, it's been restored to that saved memento state.